Hi, in this video we're going to continue looking at extended unpacking. So first let's define a list. Let's put 6 elements in it. And let's see how we might retrieve the first element and then the rest of the elements into 2 separate variables. And we're first going to do that using slicing. Now, if you're a little rusty on slicing, don't worry about it. We are going to cover slicing in a lot more detail later on in this course. So for now, here's how we might do it. We might say A equals L0, that's going to be the first element, and B we want to be from the second element, so starting at index 1, all the way to the end. And so we use this notation. So now we can go ahead and print A and print B. And indeed we get that A is the first element and B is the rest as a list. Now, you can also simplify this just slightly. We're going to use unpacking to do it this way. So we really haven't changed how we did this. The only thing that we changed is that we're now using this parallel assignment, which is just unpacking this tuple into this one over here. And so we get that result, the same result. So now let's go ahead and do it using unpacking. Extended unpacking, we're going to use the styled expressions here. So we can say A comma star B equals L. And when we do that, Python is going to look at this list and it's going to say, okay, I'm going to take the first element of the list and assign it to the first element here. Then it looks at this and says, oh, you want the rest of it. You want the rest of that list to go into B. And so A is 1 and B is that list, 2, 3, 4, 5, 6, the remaining elements. So it's the same thing as doing it here. There is one major difference though between using the slices that we have here and using the extended unpacking using styled expressions that we have here. This, remember, will work when L is any iterable. This slicing here only works with iterables that are actually indexable. So, for example, you would not be able to say, let's say that we have S is the set 1, 2, 3. You would not be able to say that A equals S0 and then B equals S1 up to the end. That's not going to work because sets do not have a concept of ordering. So there is no first element and second element. So if you try and run that, Python's obviously going to complain. It's going to say, no, you can't do that. And we saw that before in the last video when we were trying to unpack sets. Okay, so be careful with that. The other thing too that I want to point out is, let's say we unpack again, but let's say we have a tuple. Let's say the tuple is, well, let's take a string actually. That will be just as easy. So S is a string. Now, of course, it's an iterable. So we can unpack it and we can say A comma star B equals S. So what's going to happen is that, remember, it's iterating through the string. So it's iterating through each character. So it's going to assign P to A and then the rest is going to get assigned to B. But if we look at A, that's P, that's fine. But B, you'll notice, is now a list. And that's what happens when you use these styled expressions. They always result in a list, irrespective of the type that you started with. So now let's look at the tuple. Let's say we have a tuple that is A comma B comma C. Let's say 3 strings. Fix that. And now we say A comma star B equals T. Then A is indeed the string A, but B is not a tuple. It is a list, right? So even though the right-hand side here started its life as a tuple, when we unpacked into B, the rest, it was actually unpacked as a list. That's always going to be a list. Okay. The other thing I'd like to point out is that you can unpack, we've always been unpacking to tuples, but you can actually unpack to a list as well, right? There's nothing that says you have to unpack to a tuple. It could be to a list as well. So let's try that. Let's say A comma B equals, let's do a string. Let's say, well, in this case, I'd need 3 if I'm going to use 3 characters in the string. And so A is X, B is Y, and C is Z. Right. So just as a side note, you can unpack into a list as well, but it really doesn't make that much of a difference because you're always going to be referencing the variables by their names, right? So there's no real benefit here to unpacking into a left-hand side that is a list instead of a tuple. Okay, so now let's continue and let's look at how we can further enhance this extended unpacking with these start expressions. We don't have to have only the first element. We could have the first element, then the second element, and then the rest equal to, let's say, the string. I'll use the string. And so we get that A is P, B is Y, the second element, and C is the rest. So that's one way that we can extend this. We can further extend this by doing this, A comma B, comma, star, C, and D. So in other words, here's how we want to unpack. We want to unpack the last element of the string into D, and then the first two elements of the string into A and B respectively, and then the rest into C. So if we do this, we indeed get that A is P, B is Y, D is N, the last element, and C is the rest, T, H, and O. Now, of course, a string is indexable, so you could use slicing if you wanted to. Gets a little more tricky. So let's see how we might do it using slicing. And I just want to do this to show you how elegant this extended unpacking can be and how it can make your code a lot easier to read. This is very self-evident, right? We're unpacking the first and second elements, the last element, and then the rest into C. That's, when you read this line of code, it's very understandable. Now let's see how we might do it using slicing. And again, if you're a little rusty on slicing, don't worry, we'll cover it in a lot of detail later on in this course. So here we're going to unpack the first element, the second element, we're going to want the rest, and then the last element. So the rest is really everything except the first, second, and last element. And how are we going to do this? Well, we're going to take S0, that's the first element. Then we're going to take the second element. Now you'll notice I'm using unpacking, I'm using parallel assignment here. I could do this, each one on its own separate line. Then what do I want? Well, let me just go ahead and take the last element first. So I want -1, right? I want the last element of the string, and then I want everything in between. So I want everything from and including T up to and including O. So I want everything from T up to but not including N, which is the last one. So I would do it this way. We would start at the third element, which is going to be T, and we're going to end at one short of the last element. So the last element being -1, of course it won't be included in the slice. And so if we do this, we now can print A, print B, print C, and print D. And we get the same thing. We get P, Y, T, H, O, and N. Now notice though that because we use the slice will return the string, right? We're slicing a string, so we get a string back. We don't get a list back. Now if you wanted to do that, that's fine. You can always convert a string to a list. We saw, for example, how to do it using assignments, right? We can do something like this, for example. Maybe I want to say star C, comma, equals C. So what am I doing here? I'm unpacking the string C into this start element. So it's just going to give me a list. It's a very handy way of doing it. If we get that, then we get indeed that C is a list. Of course, you can also do something different if you want. There's more than one way of doing this. You can just convert C directly to a list, and you get the same thing. So whichever way you want to do it. But you can use unpacking to transform that string into a list of characters, or you can just use the list constructor. That works equally well. Okay, so now we've looked at how to unpack using start expressions on the left-hand side of an assignment. We can actually also use those start expressions on the right-hand side of the assignment. So let's see how that might work. Let's go ahead and say L1 equals 1, 2, 3. So we'll take a list 1 with 3 elements, and we'll take list 2 equal to 4, 5, and 6. So we'll make the elements distinct for now. And let's go ahead and join these two lists together. So L equals star L1, comma star L2. And I don't want to join them in a set. I want to join them in a list. We'll see later that we can actually join them into a set as well. That's not a problem. So if we go ahead and print L, now we see that L is 1, 2, 3, 4, 5, 6. Essentially what happened is that it unpacked L1 right here, and then it unpacked L2 right here. And then we were able to then create a list that contained these two. So it's just a very handy way of joining two lists together. Now, of course, this works with any iterable. So it doesn't have to be just lists. You could say L1 equals 1, 2, 3, and we could have a string, let's say, and let's take ABC. And now we can create another object, and I'm not even going to assign it to a variable and then print it. We'll just do it directly and print it. So we'll do star L1 star S. And of course, what we get back is 1, 2, 3 and ABC, right? It unpacked L1 and unpacked S. Now, of course, you can also use, let's say, a list and let's say a set. Let's call set, let's put in X, Y, and Z, just to keep it different from the last example. And we can, of course, unpack into a list. And we get the same thing, 1, 2, 3. Now, 1, 2, 3 will retain the order. But the set, remember, doesn't have a guaranteed order. And so we don't get that, right? We just get that it could be in any order. In this case, Z happened to come back first. And it works the same way with dictionary unpacking. It will unpack the keys by default, or you can use the .values method to unpack the values, and so on and so forth. Now, you don't have to unpack, into a list. Here I'm unpacking things into a list, but you don't have to. So let's take a look again at an example. Let's say we have string 1 equals ABC, and string 2 equals CDE. Now you'll notice that I've got the same character C here and here. So we can certainly unpack that into a list, right? We can say star L1, star S1, star S2. And we get A, B, C, C, D, E. You'll notice that the C is repeated. It's okay to have repeated elements in lists. And we have that. Now, what happens if you just want to create, let's say, a sequence that contains all the characters of S1 and S2, but without repeating the elements? Well, that's pretty straightforward. We're going to unpack into a set. So we'll unpack into a set, and we'll say S1 and S2. And here we go. So now we do not have the character C repeated because sets don't allow repeated characters. So it basically ditched it. And we'll circle back to that a little bit later in this video. And of course, also in the section on sets. So talking about sets, let's go ahead and see how this works with sets as well, right? Remember, this extended unpacking can work, and I'm going to now go back to unpacking on the left-hand side of the expression, can work with any iterable. So with a indexable iterable, you can use slicing if you want to, or you can use this extended unpacking. With non-indexable types, like for example sets, you can't use slicing, but you can still use this extended unpacking. Let's go ahead and take a look at an example. Let's say we have this set here. Again, the element types don't have to be homogeneous. And let's see first, if we iterate through S, what we get. Okay, so again, you can see the order is not guaranteed. So here the character came first, and then 10, then 3, and then -99. But of course, since it's iterable, we can unpack it. And we've seen that before, right? We could say A, B, C, D equals S. We saw that in the last video. And now if we print A, B, C, D, we get, D, 10, 3, -99. So that works the same as before. But of course, styled expressions work here as well. And we can say A, comma, B, let's say, second element. So we're talking about the first element, the second element, and the rest, okay, equal to S. Now, there's an issue here because the first element doesn't mean 10. The first element has no real meaning. It's going to be whatever first element comes back in the iteration. So in fact, it's going to turn out to be D in this case. And the second element will be 10. But there is no ordering in sets. So, doing this kind of unpacking here, yeah, it's not that useful. It works, and there might be some use cases where you find that you want to do that because maybe you've got a set with 2 or 3 values and somehow you want to split them up into 3 variables because you want to work with them independently, and that's perfectly fine. Then that works. But you're not guaranteed, of course, of the order of which element is going to be assigned to your first variable, second variable, and so on. So in fact, if we take a look here, if we look at A, well, A is D, right? Even though our set was initially defined in this order. And our second element, quote unquote, is 10, which was the second item in the iteration. And then the rest, well, yeah, the rest will come back. And of course, it comes back as a list, even though we started with a set, with whatever wasn't unpacked into A and B. So it works the same way. The only thing is, because of the lack of ordering, it's a little bit less useful. Now, for example, let's go back and look at something we saw earlier. And that can be, on the other hand, quite handy. Let's say you want to transform a set into a list. So let's say we have this one. Well, let's take the same set, right? We have our set S already. Well, there is one way of doing it, which is to use the constructor. And now you just get a list. Okay, that's one way of doing it. But the other way of doing it is to say something like star C comma equals S. Now here we're going to unpack S into C. We're going to unpack, there's no first or last element. We're going to unpack, therefore, everything into C. And of course, we have to make the left-hand side a tuple or a list. But let's just stick to tuples. And so if we do that, we get the same thing. We get that C is now that list. So again, it's a handy way to unpack something into a list when it may not have started off as a list. So let's also look now at sets again. Let's say we have two sets, 1, 2, 3, and S2 equals 4, well, let's repeat it. Let's say 3, 4, 5. Okay, we have these two sets, and let's say we want to merge those two sets. And we've kind of seen this before, right? So you should know how we're going to do that. Yeah, you cannot use S1 plus S2, right? Plus is not defined for sets. Now, when we go and look at sets later on in this course, we'll see there's other ways of doing this. We can use something called the union. But for now, there's another way we can do this. Let's say we want to combine S1 and S2 into a single item, into a single set. Well, we can just unpack it into a set, right? We can just do this, and we get 1, 2, 3, 4, 5. So we just use the unpacking. So this is like unpacking on the right-hand side, right? So C equals that, right? And then C is equal to 1, 2, 3, 4, 5. And you might think, well, okay, why not use the union? Sure, right? We can use the union. And if you need to look, you can look at the help on set. And if you scroll through that, you'll see that there's a union operation. There's a union function, essentially a method that we can use. There we go, return the union. So we could say S1 dot union S2. That works just fine. We get the same thing. So here you have 3 different ways of doing the same thing. Choose whichever one is most appropriate in the context that you're working in. But what happens if you want to do more? Let's say we have S1 equals 1, 2, 3, and we have S2 equals 3, 4, 5. We have S3 equal to 5, 6, 7, and S4 being the set 7, 8, 9. Okay? And you want to union everything together. Well, sure, you can use union as well. You could say S1 dot union S2 dot union S3 dot union S4. That's one way of doing it, and you get that union. Of course, union works a little bit better than just that, so we can also do union S2, S3, S4. We can do that as well. But there's also a cleaner way, actually, of doing it, which works the same, which is the unpacking, right? So we're going to unpack S1, unpack S2, unpack S3, unpack S4, and we're going to unpack it into a set. Now, here, that's the advantage as well. We don't have to unpack into a set. We can unpack into a list, in which case we'll get the repeated elements. And then you can do something with that. Maybe you want to count the number of times each element appears in that list. So that way you know the number of times that each element appears in each set, or in the union of the sets. Well, it wouldn't be the union of the sets because sets, of course, don't have repeated elements, right? But you understand what I'm getting at. So you can do it this way, or you can just unpack directly into a set as well. Okay, this will work the same way, except now we don't have the repeated elements. So this is just maybe a little cleaner than doing something like this. Kind of depends, where you're working, where you're typing this in. Maybe you're doing this in a function call, in which case this might look better than this. They're all equivalent. You can do whichever ones you want. The advantage, though, is that you can also do that with dictionaries. So we can use the star operator for dictionaries. So let's go ahead and look at an example. Let's say we have key 1 with a value of 1. And let's call it key 2 with a value of 2. And then we have another dictionary with the same key. So I'm repeating the key. You'll notice key 2 is repeated, but I'll give it a value of 3. And key 4 will take a value of 4. So now we have two dictionaries, and we want to merge those two dictionaries together. Now, there are other techniques of doing it, but a very, very simple way is to create a new dictionary where you unpack the dictionary. Now, we've got to be careful, because if we use this, what's going to happen? And in this case, well, I'll leave the curly braces. What do you think is going to happen? What happens when we unpack a dictionary? We get the keys back, right? So in this case, we're unpacking the keys of D1, the keys of D2, and then we're popping that into a set. So we get key 1, key 2, and key 4, right? So that's the thing here, is that we're unpacking just the keys. We can, however, unpack both the key and the value as pairs into a dictionary. But instead of using the single star operator, we use the double star operator. And the double star only works with dictionaries. So we can do it this way: star star D1, star star D2. And we get what? Well, we get the merged dictionaries. But notice the value of key 2. Key 2 has a value of 3. That's because D2 was merged last, and therefore the value for key 2 basically overwrote the value that key 2 had when we unpacked D1. So the order in which you do it will matter. So if we do D2 first and then unpack D1, you'll notice that the value of key 2 is 2. So just something to bear in mind. Now, you can also unpack dictionaries as you're creating dictionary literals. So maybe I'm creating a dictionary here, A with value of 1, and then I got B with value of 2, and then, oh, I need to put in D1 while I'm at it, and then I'm going to put C with a value of 3, right? So that works perfectly fine. We just get that D1 will be merged inside of this dictionary. Note here, by the way, the order in which this was displayed, in which it's being iterated, is not the same as the order in which we actually specify the items in the dictionary. Again, sets and dictionaries do not guarantee order. Okay, the next thing we need to look at is nested unpacking. So with nested unpacking, we saw that in the lecture, it's pretty straightforward. We can do something like this, okay? We can say A, B, comma, C or E is equal to, let's say we're going to unpack this list, 1, 2, and then we'll unpack the string XY, okay? So what's going to happen is that A is going to be 1, B is going to be 2, and E is going to be the string XY. But of course, a string is also iterable, so you can unpack it. So you could say C comma D equals E, right? And so now C is X and D is Y. So we can actually specify this directly over here. Instead of unpacking into E, we're going to unpack into a subtuple, essentially, C comma D. And we're going to make that equal to 1 comma 2 comma, so same thing as before. We're going to unpack the same right-hand side. But now when we do this, we have A is 1, B is 2, C is X, and D is Y. So that is nested unpacking. Now, of course, you can even do something like this. You can say A comma B comma, and I'm going to take C, D, and star E, and I'm going to make this equal to 1, 2, and then we'll take a longer string. So let's take Python. What's going to happen here? Well, 1 is going to get unpacked to A, 2 is going to get unpacked to B, and then Python is going to get unpacked to this tuple. But this tuple is itself getting unpacked, right? We're going to unpack Python into the individual elements. So P is going to go into C, Y is going to go into D, and then the rest of the string is going to go into E as a list. So in fact, when we execute that, we do get that A is 1, B is 2, C is P, D is Y, and E is the rest of the string as a list. So THON. So do you remember the challenge that I posed to you in the last video? So this is basically how can we do the same thing here, but using slicing instead. So let's take a look. Let's start with a list, and we'll make it 1, 2, 3. I'm going to just make it a little bit longer because I want to show that I'm not going to hard code any values. And so I want something that can work with either, any length of list and then also any length of string. So let's go ahead and do that. And let's take our list. So remember, if we were to use unpacking, we would simply use, and I'll copy paste that, make that equal to L, and then we can print A, B, C, D, and E. And so we get 1, 2, 3, 4, P, Y, and then THON as a list. So let's do that now using slicing. So the first element we're going to want to look at is going to be the first. So that's the first element. That's 1. Then we want the rest except for the last element. So let me just take care of the last element, which is going to be L negative 1. Now we're not quite done then. Here, now we want to take everything in between. So we're going to go from 1 to negative 1. Now for this last element, I don't want to just bring it back, as a string. I want to break it up into the first character, second character, and then the rest. So we want to take the first character, then we want to take the second character, and we want to take the rest of the string. So we're going to start at character 2 and we're going to go all the way to the end. So when we do that, we're almost there, right? We have 1, 2, 3, 4, P, Y, and then THON, but THON, you'll notice here, is a string. And we want that as a list. Well, that's pretty straightforward. We can just use the list constructor, for example. And if we do that, then we get back exactly what we had over there. So then if I wanted to get exactly this, I would have to say A, comma B, comma C, comma D, comma E equals, and then we'll do this parallel assignment. We'll unpack this tuple basically into this tuple over here, and we can then print everything out and we'll get identical result. So 1, 2, 3, 4, P, Y, T, H, O, N. As you can see, it's identical. Now, of course, this will work for any list, L, and this will work actually, and this will work for any string, but moreover, it will work for any iterable type, right, that is indexable, and it will also work in the outer one for any iterable type that is indexable. So for example, we could do something like this. This will work equally well. We might take, let's say, a tuple, and we're going to, instead of using a string here, maybe we'll use a list that contains, 3 or 4 elements. So if we do that, then unpacking using this, so let me just copy paste this code. So if we do that, we get 1, 2, 3, 4, A, B, and then C, D. And using this method here will work equally well. We'll get 1, 2, 3, 4, A, B, and C, D. Notice, however, that B here, because we're slicing a tuple, is returning a tuple. So again, we would have to fix that in order to get a list. If we wanted to match exactly what we have here, we would have to make this into a list. Okay? And so this achieves the same thing. So you can see this is a very elegant way of unpacking. Certainly, you can use it using slicing, right? You can slice instead, or you can use unpacking. The other advantage of unpacking is that it works for any iterable, not just sliceable types. So for example, and it's less useful maybe, but instead of having, let's say, a string or a list here, maybe you've got a set, right? Or maybe this is a dictionary and you want to unpack things. So again, the unpacking is a little more general than slicing because you don't need indexable collections. All right, thanks for watching, and I'll see you in the next video.